wanted to go over just a couple of real quick things here. Please make sure that your mic is mute until you wish to speak. The meeting, again, is being recorded, and we'll have that available shortly after the meeting. And we'll share the link associated with it. We did put it on our division YouTube channel, which is something that we've kind of resurrected, but please use that. It's your tool, it's your instrument. Use that as you wish. So without further ado, I think first up on the discussion is WSU. Pierre, are you available?
I am, sir.
Take it away, sir.
All righty. I will share here, at least attempt to.
Perfect.
See the screen there?
Yes, sir.
Better flip screens. There we go. Is that full screen now?
Yes, sir.
All right. Well, thanks for the time, Ray. So Pierre Harder, I'm Associate VP for Research here at Wichita State and Industry Engagement. What I put together, something similar to what Kurt shared last week about K-State Salina. I've got kind of pulled together several different groups. I'll show you some of the labs that we have at NIAR that have been and will be supporting AAM activities historically and going forward, just to kind of give people an understanding of the capabilities and what we're doing today for the industry. And then I pulled a couple slides from WSU Tech to talk about what kind of curriculum they have and are developing to support this sector of the industry. And then a slide from our engineering department that goes through their curriculum and what they provide as far as supporting AAM and emerging aviation. So I'll go through some of these. I'll go through really quick because I want to stick to my 15 minutes here. I probably have more slides than I need. So, but I figured, Ray, you'll probably be at one point distributing these presentations, and plus people will be able to look at them in more detail if they want to spend time on the YouTube channel. So, and then of course, if anybody wants to go deeper into any of those subjects, you feel free to reach out to me and we can set something up separately. So maybe click through. So NIAR, first of all, National Institute for Aviation Research here in Wichita. We also recently opened an office in Huntsville to support our Army and NASA customers down there. We did over 300 million last year in research expenditures, got about 2 million square feet, cut across 6 different locations. I'll show a map on the next slide, and about 1,900 employees, half of which at any given time roughly are students that are working in our labs directly on applied learning and applied research projects. So 4 main sites, our main campus where we have a bunch of different labs up north where we do our full-scale structural testing and our digital twin activity among some other items. Co-located with WSU Tech at the National Center for Aviation Training. We have several of our labs there. And then down south, we have a complex that hosts our NIAR Works team, which does modification, repair, overhaul work, design work, flight test work. Our Atlas, which is part of our advanced manufacturing with composites. And then our National Defense Prototyping Center, which is a joint center with Spirit Aerosystems that focuses on prototyping and high temperature material characterization and has the ability to go classified down there. So core competencies of NIAR, we're supporting AAM in all of these. Predominantly though, the focus is test and evaluation, some certification, flight test, prototyping, and a lot of materials work, modernization, and getting started in on helping folks in the industry in manufacturing and automation and robotics in their factories as well. Those are our main core competencies and supporting this part of the industry in all of those areas. A smattering of most of our labs. I'll touch on the ones that are predominantly supporting this industry sector, but those are there if people want to dive deeper at a different time. So really starts with kind of the very beginning of any type of aircraft program is figuring out what materials you're going to use. So we have a national center of excellence here where both FAA, EASA, DoD, and industry partners all come to us to help them pick materials and qualify those materials. FAA and EASA have delegated us to do that testing, and they will accept that data for certification if it's done here. We've recently added capability to go up to 5,000 F, so that's hypersonic type of speed. So getting up into the Mach 10, Mach 15s, and the type of temperatures you see at the tip of those type of aircraft. And we do have some folks that are unmanned aircraft in that type of regime. Not many, but we have seen some. And of course, working with all different types of materials, so all different types of composites, which are used extensively in these type of aircraft, and then more and more we're seeing additive. So we do both metallic and non-metallic additive material quals and characterizations. And then as we move up the building block, we can go anywhere from component all the way up to full scale structural testing. So up north of town, we have our large test facility. We do fatigue, static, durability, damage tolerance. And it's all custom built, custom designed to support. So like right now we have actually 2 large unmanned aircraft up there. We have the MQ-4C Triton, which is a Navy aircraft, and we have the Sky Guardian, which is kind of next generation Reaper Predator for the UK government is the first customer for that. And both of those are going through a durability and damage tolerance test. So of course we can go big. The Triton that we have up there, that's the wingspan of a 737, but we can do, like I said, components or small aircraft as well. We do have several AAM companies that have been in discussions with us, and we do have some of those aircraft coming down our pipeline to helping them achieve certification testing on their structure in the coming years. Moving on to the manufacturing side of things. So we have our Atlas labs, have several different sectors, some here on the main campus, some down south, and about 130,000 square feet down there where we have advanced manufacturing for composites. So everything from automated fiber placement and tape laying to filament winding, welding techniques for thermoplastics, bonding for thermosets and thermoplastics, a very large autoclave. So we have a lot of companies that are coming in, including AAM companies that are coming in to do proof of concepts, to do prototype work. In some cases, we're even helping building some of their initial flight test vehicle structure with them and for them. This is all industrial scale type of equipment, much of which that we believe will be employed in the manufacturing of these vehicles, both thermoset and thermoplastic capabilities there. So a lot of the companies are coming here because they're kind of trying before they buy, figure out which equipment works for them before they go invest tens of millions of dollars in capital infrastructure. Also, a lot of investment and expertise in additive manufacturing. We're seeing quite a bit of this, especially in the smaller vehicles being employed. We've got about, like you see there, about 50 million in equipment investments. Either we have them or they are on order and coming in. And it's not just the printers, but it's all the post-processing that goes with it. So the machining, the hipping, the different thermal post-processing that goes on with those. All of that equipment is kind of scattered across several different labs right now, but we just broke ground in May on this hub for advanced manufacturing and research, HAMMER for short. It'll be a large building here on our main campus, about 160,000 square foot. So we got a grant from Department of Commerce, Federal Department of Commerce, and then supplemented that with some state money. So about $100 million going into this building and equipment, focused primarily in 2 areas. One is regional workforce training, so helping all the various machine shops and other manufacturing entities here in the state and regionally on how they can train up their staff and their workers to get them trained up on advanced manufacturing techniques. So additive, high-speed machining, smart manufacturing, smart factory type of technologies, Industry 4.0 type of stuff. So workforce upskilling and training, as well as then facilitate all that equipment and all that expertise there will facilitate research in those areas as well. So moving on, different lab, NIAR works. So this team is set up down south. So we have about 400 engineers, about 26 different DERs, FAA DERs, designated engineering reps across a multitude of structures and systems, and then about 250 mechanics and technicians. So we're doing all different types of special mission modifications, large commercial transport to freighter type of conversions, and then not just the design work, but the turning the wrenches, modifying the aircraft, doing the flight testing and other work required to get STCs with the FAA and other regulating agencies, and then providing a finished product to our customers. So a lot of focus down there. Most of it traditionally has been fixed wing, commercial, and general aviation aircraft, but we have been and are starting to see more and more eVTOL and other AAM type of aircraft that are coming to get help from us in these areas. We do have a Part 145 repair station down there. Right now, mostly the commercial aircraft, but the facilities are there, the skill sets are there, several large hangars. So this is McConnell Air Force Base. Those of you familiar this is kind of on the Spirit side of the airfield on the west side. So this building right here is Spirit 787 final assembly, if you're familiar with the area. And then we've got a hangar up north. We have this brick building, which used to be Boeing military. And then we have this large hangar here where Air Force Ones used to be born. And then we built two other hangars since then, these two here. It's just a different view with some stats there. So I'll keep skipping through these. We also have a flight test center there. With the ability to do flight testing and telemetry here off of McConnell's Air Force Base. We've also used Salina's Airport for offsite operations. We do have a mobile telemetry trailer that can travel with that if it's out of line of sight from Wichita. So the ability to take all the data, evaluate it, report on it, as well as planning and execution of the flight test programs. We have a large instrumentation team and all the telemetry and mission control apparatus in place as well. And then a team that's very familiar with putting in, this orange equipment or all the test equipment that you put into your flight test aircraft to gather data during flight test. We also just broke ground recently on this restrained flight test facility. So it'll have the ability to do in-ground and out-of-ground effect testing with these two different test sites. So these are recent pictures. I think these are as of like May as far as progress goes. So we'll have that ability at our site as well. Also in discussion with the local eVTOL company on providing a flight test area in and around Wichita, potentially, extending up through Salina and I think we've already started some discussions with Kurt and his team at the K-State in support of that as well. We also have environmental test lab focused on the system side of qualifying aircraft. So these are your avionics boxes, your hydraulic systems, all those type of things that need to get shocked and vibrated and struck with lightning and looking at indirect effects and all those type of things. So system level testing. And then all the way up to full aircraft testing from a HERF and P-static standpoint. And we have the ability to do that on site, and we can also deploy and set up Faraday cages and do this on site for different customers. And we've done that all over the world. Our AVET team has also been doing quite a bit of research in this area, and they're coupled with FAA Assure as well as some NASA programs. I know Kurt and his team are involved in a lot of these studies as well, K-State Salina. so this is just a smattering of the different projects that we've been working on. So a lot around digital engineering and digital twins, doing quite a bit in crash worthiness of the aircraft structure, as well as crash worthiness of the batteries themselves, and helping to develop test methods and methods of compliance for doing that. And then supporting a wide variety of other studies that DFA has been doing through this Assure program on kind of the regulatory atmosphere, the policymaking atmosphere, and then how do we track and control all these aircraft in airspace. That's just a listing of some of the other tasks on that FA Assure. And I know Kurt's been involved in some of these, not sure how many of all of these, and maybe some different ones as well, but there's some good collaboration within the state on these type of efforts. And then a project we have started, but certainly gonna push forward more is creating not just the ability to do, virtual flight test, but this is embedding the physics of the aircraft into the virtual test atmosphere so that you can not only fly it around, like a simulator, but it is also collecting all the systems and structural data from the different inputs that you put into the system. So, the vision here is really to create a flight test laboratory, which we have this, all this hardware in place. But really to create a physics-based real-time digital twin environment. So this is something that we're proposing with K-State, Salina, to create this virtual environment where people can come in, test out modifications to their aircraft without having to go through a full-up real flight test, in the hopes that in the years to come, with the amount of these aircraft and just the cost and complexity of doing real flight tests, that if we can create a physics-based digital twin of these, that perhaps we can shave time off of certification and we can help our customers get to market quicker and deal with modifications in a more expedited fashion virtually. And then I'll wrap up here and I'm at time. So few more slides here. So WSU Tech, which used to be Wichita Area Technical College, about a decade ago, affiliated with WSU. So we have the ability to offer, anywhere between GEDs all the way up to PhD, and everywhere in between. So WSU's tech curriculum, we have very similar to what Kurt showed last week, a lot of different typical 2-year type of programs. If we're getting, kind of the equivalent of A&P licenses, we do have 1-year tech certificates in these. And then in some cases, when we're talking about upskilling existing workforce, we have certificates of completion when they just need to fill in a small gap. So those are the programs that they have at WSU Tech. We also have a NASA grant. NIAR has a NASA grant, and they've sub to WSU Tech to jointly identify these different areas of the industry where we have challenges with respect to maintenance and repair and curriculum that's currently being taught for existing commercial and general aviation aircraft, and where those may need to be modified to support AAM industry partners. So that'll be a joint effort between WSU Tech, NIAR, and AAM industry partners to identify what type of things we need to do to upskill our workforce in the future to support these airframes. And then finally, our College of Engineering offers a wide variety of different engineering bachelor's, master's, and PhDs. So, aerospace is really what we're known for here, but we have strong electrical and computer engineering programs that are supporting. We're seeing a lot of interest from AAM and other companies in these areas to support, automation, to support their flight control logic, all those type of things. Industrial and systems manufacturing engineering to support, shop floor activities and building these facilities and running them efficiently to manufacture the products. And then, of course, our mechanical engineering team has a materials engineering emphasis to support all the work that goes into materials in these aircraft and their structures. And I think that is it. I think I made my time there, Ray, but
you did right on time. Any questions for Pierre? Thank you, Pierre. That was awesome.
You're welcome.
Any questions? One of the things that I saw is the digital twin lab, and I see that as a unique item that can potentially draw in traffic. So we have some amazing academic institutions in the state that are very aviation centric, and hopefully as our discussions move forward, our communication, our mouthpiece needs to show off these various assets to not only, again, work together, but also promote Kansas in numerous ways. So I'm excited to kind of see where this develops and hopefully form that outreach component through, hopefully supported through this discussion. Um, our next presentation will be by KU, Dr. Ewing. And Dr. Ewing, I just noticed that I dropped off your last name from the list. So please excuse me for that. And I'll update the roster here shortly so we can properly have you stated on there. Take it away, Dr. Ewing.
Okay, let me share my screen. Oh boy. Is that doing it?
There it is. Yes, sir.
Okay. Okay, so I'll be talking about urban air mobility and advanced air mobility, or whatever you want to call it, focusing on the work that we've been doing at the Flight Research Laboratory and ITTC, the Information Technology or Telecommunications and Technology Center, but also sprinkle in some information from some of my KU aerospace engineering colleagues that are online. So I'll talk about past and current activities, drill down to some of our core competencies, and then some efforts that are going on right now that I think will be able to be leveraged towards the state of Kansas and would ideally involve people from the other institutions, various companies. So to start off with remote sensing in the cryosphere, Antarctica and Greenland, we, the Flight Research Lab, got our beginnings in the UAS domain by providing the drones, basically the UAS, for remote sensing in Antarctica and Greenland. ITTC has provided the radar, and we're funded by various national sources of funding. A lot of deployments to Antarctica and Greenland. Some colleagues on today, Rick Hale and Emily Arnold, have been on some of those deployments, as have I and Sean Kishmiri, also at the Flight Research Lab. Flying large UAS up to 85 pounds, so exceeding the 55-pound barrier for small UAS that we see in the U.S. I should mention that in our flights in the cryosphere, we're largely beyond visual line of sight, and we didn't have anybody telling us how to do that. It was the Wild West. But more recently, we've been working with the FAA through the Assure Center of Excellence, and I'll just highlight a couple of things that may relate to AAM. The first one was involving wake vortex interactions between UAS and crewed aircraft. And so we got into discussions on what happens as a wake vortex descends below a landing large aircraft or a taking off aircraft. And issues of wake vortices blowing laterally due to crosswinds and whatnot. So if we're talking about advanced air mobility at an airport, we have to worry about the wake vortices, not only if we're operating, crossing the path of a large aircraft, if we're laterally separated from it. So that's one of the things that we worked on, also involving our colleague, Hyung Chow, who's been doing a lot of flight testing with some remote sensing, especially sensing fires. A project just closing up in a couple months is looking at UAS detect and avoid systems. And in particular, we've been focusing on the requirements for detection to avoid right-of-way violations. So you've got part of a detect and avoid system is detecting your adverse air traffic. And so the research we've been doing is trying to decide how far away a detection system on an aircraft would have to identify adverse traffic. And so we've done things like simulating, we have a crewed aircraft coming against an aircraft, a drone, which is doing some sort of, let's say, mapping or whatever. And we've figured out at what distance you need to identify this traffic, this adverse traffic, and then be able to avoid, maneuver around the basically the well clear volume, 2,000 feet laterally separated from a crewed aircraft. So we've studied it in simulation and in flight testing. A project we're in the middle of is trying to determine the role of UAS traffic management. So that's at the core of advanced air mobility, urban air mobility. You've got to be able to have an automated system that can separate aircraft. So we're teamed with a European company called Unifly, which provides separation services. So they're actually coming to the U.S. A couple times, both to visit us and our colleagues up in North Dakota. And the big question is, can UTM provide physical separation services that enhance or possibly even replace detect and avoid systems? So if, for instance, ADS-B fails or it's not used, like an ag aircraft, the cowboys of flying, if they are flying through, let's say, a corridor that a UAS is flying through, we want to be able to detect it, even if they're not broadcasting on ADS-B. The question is, do you have enough capability from a radar system to provide that separation? And that the radar has some pretty big latencies. So you see an aircraft at one point, the next time you see it on radar is maybe several seconds or later. So we're studying things like the uncertainties that come with using a system like radar. So I haven't covered all the things that we're doing with Assure, but just to list what we think of as our core competencies, especially at the Flight Research Lab: guidance, navigation, and control for precision flight, cutting-edge algorithms, including those leveraging artificial intelligence, machine learning. We have a long history of one-off UAS design, build, fly. Starting 10, 15 years ago, our colleague Rick Hale and some students that have gone on to great things in the aerospace industry designed, built, and flew a 1,100-pound drone that was flown in Antarctica and Greenland. So we have the ability to do that design, build, fly. Wichita State also has those capabilities, but I just wanted to mention that's one of our strong points. In the area of UAS autonomy, intelligent decision-making autopilots, you might think of them as flight directors. And looking into the adaptability to adverse onboard conditions or failure. That's one of the grants we're working on through the FAA, looking at automation failures. In terms of the Flight Research Lab, probably the high point of our activities, our expertise, are validation and verification flight testing. for both unmanned, fixed and rotary wing vehicles, and also manned and unmanned teaming, which I'll talk about here in just a little bit. And then working with our colleagues in the in ITTC, expertise in 5G networking, and something that we've been pioneering, which is a mesh network, which enables U.S. flight information or flight along corridors, having aircraft be able to talk to one another. And then cybersecurity, also very important. So I think the bottom line is that the not only here at KU but anywhere, the investments that we've made in drones basically enables urban air mobility, advanced air mobility. In other words, we provide this surrogate UAS flight testing, design of communications and command systems that will then be used when you don't have unmanned aircraft, you've got people involved. Just mention very quickly a couple of grant opportunities. We're looking at an NSF grant. We've stood up a grant writing team focusing on the smart cities concept. So that would include linking both airborne and ground vehicle operations. So think package delivery, getting the ground the ground vehicles to the vertiport at the right time. Police operations, emergency operations. So we think that this leverages our expertise in advanced communications, command and control, and then C3, command control and communications all lumped together, and then the validation and verification flight testing. We've been talking with our endowment association for identifying some land to basically stand up a virtual smart city, possibly flying from the Lawrence Regional Airport, where we have a hangar along the corridor to an area that we've got northeast of town. Also possibly using areas next to the airport. So speaking of the airport, we've been engaged with the city of Lawrence in their airport planning operations. Looking at UAS facilities, they're talking about having some UAS facilities just south of the Hetrick facilities there at the airport. Also, possibility of a vertiport. So I think there's a lot of opportunities, and we talked last time when this working group got together about any city that's worth its salt is thinking about drone operations and vertiports and whatnot. And finally, something that ties in, sort of a parallel thing, is we're working with the Office of Naval Research, looking at combined air and underwater operations with its unique communication paradigms, where you have to go from operations above and below the sea level. Unique command and control issues. Those are also important for the smart city, the AAM, UAM operations. And it's something that's got a lot of attention these days, trying to come up with ways to counter both Russian and Chinese, we'll call them incursions into Arctic operations. But the bottom line is it leverages the same expertise as the smart cities idea. So I would say that between the smart cities, this ONR opportunity, and this KDOT-led Kansas-wide, if you will, consortium, we have a lot of capabilities to play in all those areas. So that's this is a hastily put together presentation, but be happy to answer any questions.
Any questions for Dr. Ewing? I do have one question for you regarding the NSF grant. Is that already passed? Did you apply for it? Are you waiting, or are you in the process of applying right now?
The smart cities?
Yes.
No, it's an opportunity out there. All we've done is formed um, a grant writing team.
Gotcha. And I mean, I'm not sure if you'd be open to it. If you want to, I mean, we can collectively look at this as a group to see if there's any kind of way to lend support. And also with, KDOT Aviation specifically, there's a couple of ideas that, we may be open to discussing that aligns with something that, we'll discuss a little bit later, but there's potential overlap there that we may be able to help with, at least from a support perspective or a collaborative perspective. So definitely would take a look at that.
Yeah, 100%. We don't have an exclusive grant writing team. We've got a few people that are looking at it, trying to expand it. Yeah, so the more the merrier, really. But we know that we would like to engage with the city of Lawrence, but that was an effort that came up before this working group was put together. So yeah, and that's really why I wanted to highlight it is I think there's complete overlap.
Fantastic. Thank you, Dr. Ewing. If there are any other questions, we can take those kind of at the end there. Next up, it looks like we have Beta Technologies. Thea, are you on the call?
Yes, I am.
Take it away.
Just share my screen. All right, can you see this?
Yes, ma'am.
All right. Well, thank you everyone, and thank you, Ray, for the time today. So my name is Thea Wurzburg. I am the state government affairs person at Beta Technologies. For those of you who aren't familiar with Beta, we are an electric aerospace company. We're headquartered in Vermont. That's where we have our main research and development facility and our headquarters, and then also our production facility that we just opened at the end of last year, where we're going to be building aircraft. We have facilities in a number of other states. We do all of most of our flight testing over the lake in Plattsburgh, New York. And then we have a few other offices. But we are developing the full ecosystem to enable electric aviation. So we kind of think of ourselves as a three-legged stool. So we have, the electric aircraft, which is definitely the, main focus of the company and what folks are thinking about when they talk about advanced air mobility and electric aviation. And I'll get into a little more detail about the aircraft that we are building and certifying. But we are also developing the charging infrastructure to support electric aviation, and then developing the training programs to support both pilots and mechanics, since this is a new frontier for aviation. We're also a little different in the industry because most other companies in the AAM space are primarily focused on the air taxi model, whereas our entry into market is focused around cargo, medical logistics, and then we'll eventually be moving into passenger missions, but we believe that it made most sense to start off with cargo. And we have a number of customers who that is their specific use case and what they were asking from us. So that's why we have that focus. One thing that we always like to touch on, and I think is definitely very pertinent when we're in Kansas, is talking about revitalizing the existing infrastructure that's already out there. We have over 5,000 public use airports in the US, and they're, vastly underutilized. And when it comes to advanced air mobility and electric aviation, initially this technology is going to be using airports that are already there. Vertiports are obviously a really important part of the picture and is something that we'll be using down the road, but that also takes a little while to figure out. And we have today all of these incredible resources out there. So at Beta, we really like to focus on figuring out how we can best utilize the infrastructure that's already out there, and also bring new economic opportunity to a lot of, especially rural communities, that have these airports already, but that aren't being used because, the traditional conventional aviation model isn't affordable. So we really focus on looking at airports that are, GA airports when we're building out our charging infrastructure. So we have 20 chargers that are online today, and I'll talk a little bit more about charging in a minute. But when we're looking for locations for those chargers, we're not right now, our primary focus hasn't been to necessarily put those at the really big airports. It makes more sense to kind of start with some of our medium and smaller airports. So these are 2 aircraft that we are designing and certifying with the FAA. We have, on the left, you'll see our fixed wing CTOL, conventional takeoff and landing aircraft. So that is airport to airport. It uses a runway. It's a little more straightforward in terms of certification with the FAA. And then we have our ALIA VTOL, which is the vertical takeoff. So that is runway independent, and obviously opens up a lot more use cases. And with our 2 aircraft, you can kind of see there's about 80% commonality between the 2 designs. So the idea was to kind of streamline our certification process and hopefully make it a little more efficient and easy with the FAA. But we do have these 2 aircraft that you see here. Those are 2 prototype aircraft that we fly regularly. We've done a lot of flight testing, and between these 2 aircraft, we've flown enough miles to go around the world at least once and a little more. So, we're really getting out there, and I've done some long distance trips as well. So on the charging side, our team has developed a specific charge product. So our Charge Cube is what you see here in this photo, and it's been designed to fit into the airport environment. You can see that it fits under the aircraft wing, so it's a little different than what we normally see with regular ground EV chargers, where they're taller. But most importantly, our chargers were all designed to be multimodal. So they use right now the CCS charging standard, which is, what the majority of the industry has coalesced around when it comes to a charging standard. So they support both Beta's aircraft as well as many other OEMs aircraft, and as well as ground EVs. So, when we're looking at airports electrifying more of their ground fleet, they'll be able to use our infrastructure to support those ground vehicles as well as any electric aircraft coming in. And we think this is, especially important, as it's going to take a little while for electric aircraft to, take off, pun intended, and for us to see a lot of them coming into airports. But because our chargers are multimodal, this infrastructure can be used on day one. And you'll see here too, so our charger, it's a level 3 charger, 320 kilowatts. It can charge our aircraft in less than an hour, and it's UL certified. We also do have a mini cube is what we call it, which is a mobile charger. So that's another option for our customers. And I mentioned this, but I think something that's really important to talk about is this industry alignment that we've seen on charging. We feel very strongly that we as an industry need to be coming together to support kind of a unified charging standard, and that has happened through Gamma, which is really great. But it doesn't make sense for airports to have 5 different chargers, one for each company. So we've worked really closely with others in the industry to coalesce around the CCS charging standard right now. And I'll say, while CCS is the current charging standard that we've, unified around, that doesn't mean in the future it won't change. But what we find important is us, all being on the same page moving forward. These are our partners. So as I mentioned, we have the focus on cargo and medical logistics. So UPS is one of our main customers. United Therapeutics on the medical side, they are planning to use our aircraft to transport organs. And they're kind of our founding customer. Martine Rothblatt helped start our company. And then we do have passenger applications. Blade and Helijet are both customers of ours, and we'll be using our aircraft to transport passengers in the future. We're also still a private company, so we have some really important and key investors here. And then we also have a very strong partnership with the Department of Defense. We've done a number of deployments with the U.S. Air Force. We were down in Florida at Duke on a 3-month deployment. We just got back a few weeks ago from another deployment with the U.S. Air Force. So we've been really demonstrating how our aircraft and electric aircraft in general can be used in military settings for logistical issues. And then these are just some of our milestones. So we've been, as I said, doing a lot of flight testing and have really been demonstrating what our aircraft is capable of. We have flown what we think is the longest flight on a single charge of a battery, so 336 nautical miles from one end of New York to the other. Like I said, we've flown enough test miles to go around the world and then some. We've flown through some of the nation's busiest airspace, so these photos are all real. We flew over Washington, D.C. and up the Hudson Corridor in New York. And then we were also the first company to perform a full piloted eVTOL transition. So that was really exciting for us as well. And then I should say, when I was talking about charging, I think I mentioned, but we have, I'll stop sharing now, but so right now we have 20 chargers online up and down the East Coast and into the Gulf. And we have 50 plus in various stages of development. But, right now we don't have any chargers in Kansas, and we are excited about figuring out how to change that. So I'm really excited for this working group and being part of this, and really appreciate everything you're all doing. So let me know if you have questions.
Thank you, Thea. I think we're excited about potentially having charger infrastructure in Kansas. I see some of the charger maps that you have, and that includes, going from the East Coast on down through Texas. But for some reason, Kansas is kind of missed in there, which hopefully we'll look at correcting, over the coming months to years as we look at minimum viable infrastructure. I like the CCS standard because it offers an immediate return for airports, like you mentioned, to have an electrified ground service fleet and ground service equipment fleet. So they're able to use it immediately and then able to accommodate the growth as AAM becomes commercially viable. So it's something that we're definitely excited about looking into, as far as looking at the right charger infrastructure. Any questions for Thea or anything on the beta? Thank you again, Thea. Next up, Brian Casson with KDOT will share some information that we have regarding KDOT Aviation's efforts. Brian, take it away.
Certainly. Just so everyone knows, my presentation is going to be scoped a little bit here as far as a very specific portion. Let me go ahead and try to share this here. There we go. Gotta love state computers, always super speedy. I must confess to everyone, I have a tremendous love-hate relationship with slides. I feel they're a necessary evil, but I really only find them necessary to give the high points. The first I want to emphasize is MITRE last time represented KDOT's efforts regarding the strategic roadmap for AAM. This actually is the guiding document that we're going to go ahead and leverage the people and parties on this call for. Traditionally, transportation planning has been a KDOT function. I want to be very clear that that continues. However, it's myopic to assume that that planning function is going to encapsulate all the good work that everyone on this call is doing. And so we engaged a federally funded research and development center to go ahead and be able to leverage cross-pollination across levels of government, not just in Kansas, but also in the federal government, to go ahead and be able to once again encapsulate and leverage everything that people on this call are doing. I wish I could say that we all know what everyone is doing, but that's not always the case if we're really honest. And this would be a means of casting the largest net possible to go ahead and help all of us help each other without at the same time stepping on each other's toes. Many states are taking these up right now. However, when I've read a lot of these, I find them to be of questionable value if we brought them into Kansas. And so we tried really hard to learn from what others have done, pick items that we liked and felt were applicable, and frankly, items that really weren't value added, we're not going to go ahead and do those. This document is going to be unique to Kansas. We're a rural state, but at the same time, we have tremendous assets in the eastern part of the state, population wise, and then we have OEMs in the form of Textron and Spirit and one of a kind centers of excellence in academia in K-State, KU, and Wichita State that really need to be brought in. So having it be a KDOT centric design and document really wouldn't benefit the entire state of Kansas. We're representing the state of Kansas, just like everyone on this group are state of Kansas stakeholders. So I wanted to address first that that strategic roadmap is going to be pretty broad when it comes to its scoping, but it's going to be very strategic as far as how we can have actionable items to go ahead and bring value to everyone on this call, but stakeholders in general. Now, drilling down a little bit as far as what KDOT's Division of Aviation specifically is doing as part of this larger initiative that I want to be really clear, we're trying to support, not stepping on each other's toes, but be accretive and not competitive. The initial one is KDOT is one of 8 lead participants in the FAA's Beyond program. FAA reauthorization went ahead and codified it, but it went ahead and also expanded and extended the program. So it's going to be for 5 more years. And in the past, much like Dr. Ewing was noting previously about small UAS was really kind of the focus for quite a while. That is still an important tool in the toolbox. I want to make sure that I'm clear on. However, like all things, it's evolving. And the program and state of Kansas involvement in emerging technology has to evolve in a commensurate fashion. So part of that is we're scoping our new MOA with FAA and determining what state of Kansas goals are going to be. In the past, our goals have been really kind of centralized on a few key areas. Those being Part 137 agricultural operations, infrastructure inspection, particularly leaning heavy into L3I2 work. For being a DOT, it only makes sense to have long line linear infrastructure inspection. But then also public safety is really a third part of this pillar that we're attacking. But having said that, I'm going to back my slide up one more. There's a unique opportunity currently with the FAA Beyond program, and I really want to go ahead and throw this out to the group to implore you, if you see areas where we can have a little bit of mutual benefit, please reach out to me. In the MOA, there was a bit of work. Many of the lead participants are also co-located with UAS test ranges. That creates a little bit of a schism as far as the 8 requisite lead participants are concerned. And so verbiage was put into FAA reauthorization, and I went ahead and included it so everyone can see it. And effectively what it does is it goes ahead and suspends 44.711 provisions, and it allows test site activity to happen for beyond LPs. This is very commensurate with what Kansas State University is able to do with a quasi, and it will allow the state of Kansas and those on this call to go ahead and test and get in the air faster, better, more efficient, and in a complementary way. I want to be really clear. This is not competing with Kurt and his team at all. Uh, they're a very important strategic partner, as are others on this call. And this is not getting in each other's way. It's to actually go ahead and have multifarious options for those that are interested in true blue legitimate flight test to advance UAS and ultimately AAM in this space. FAA has made it abundantly clear part of the broadening of the scope is to go ahead and include larger aircraft, and much larger than Part 108, which is the notice for proposed rulemaking is coming out, and it's looking like it's going to be an LSA size aircraft of 1320 MTOW. So the gist of what is coming forward from KDOT and those that we want to partner with, Kurt actually alluded to this a little bit last time with a 44807 exempted aircraft project that we have between our organizations for the Helio Part 137 spray drone, which is a 400-pound aircraft, going to bigger aircraft in the hundreds of pounds, then transitioning to aircraft in the thousands of pounds, of which I have a partner from Israel that is going to come stateside Q1 or Q2 of this new calendar year 25. And it will pivot us into a larger series of aircraft, along with some of our other strategic partners who are having aircraft that are 1,500 to 2,000 pounds. I went ahead and included the graphic here from FAA. Phase 2 is encapsulated by bigger, farther, higher. And it's really simple to note what that means. So this includes Dr. Ewing's work that he was discussing for C3, which I have a lot of questions about, particularly for C2 and then payload for the third part, what spectrum that entails, and statewide connectivity are a big part of this. And so these are the pillars that KDOT is taking on when it comes to autonomous systems, uncrewed systems, and ultimately the crown jewel of what all of us are dealing with here, which is advanced air mobility. And that advanced air mobility model being agnostic to platform type. I really appreciated Thea showing, and it's one of the things I really like about Beta, frankly, as a business model. They're not exclusive to eVTOL. I get a lot of chafing personally when eVTOL becomes the proxy for AAM, because I'm really not convinced, and I believe the MITRE study and plan are going to show that the system will vary depending on the part of Kansas as far as AAM is concerned. What is best for the eastern part for a KU game could be an eVTOL, and cargo delivery in western Kansas could very likely be a CTOL for cargo. And they don't have to be the same platform on both sides. So the last one I will throw up there is my contact information for those that are interested in regulatory assistance and access to FAA, particularly going forward as I write the MOA with FAA for our goals and objectives. If you have any questions, please hit me up. Appreciate everyone's time.
Thank you, Brian. I think it's really exciting because we've already identified areas where there is overlap, and there's areas where we can contribute to, again, KSU's efforts, WSU's efforts, and now hearing Dr. Ewing, potentially to Dr. Ewing's efforts, and have that cross-pollination that we just discussed. So very exciting. Thank you guys for coming together. If there are any questions, please don't hesitate to speak up now or forever hold your peace. Next meeting will likely be sometime in August. I'll send out an invite after hopefully looking at dates and times that are not competing with anything major. So we'll take a look at that and hopefully try to send that out here shortly. Appreciate it. The recording will be made available after the meeting, and I'll send that information and the link out in case you guys have any questions. And please also do not wait until the next meeting. If you recognize some opportunities for collaborative discussion, do not wait until the next meeting. Have these offline discussions, bring back your discussion to the next meeting. That will help move the process along. Thank you for taking time out of your Wednesday. If there's nothing else, I will end the meeting. Going once. going twice. Thank you, guys.
Thanks, Ray.
Thank you.